My OrangePi originally ran Debian 12, so I wanted to install the new Debian 13 version. After searching around, I discovered this new product called DietPi. It lists supported hardware. What we call single-board computers, or SBCs. There's a specific term for them, SBC. If you've never encountered an SBC before, this is actually a great opportunity. For instance, it features some well-known hardware options. Of course, there's the Raspberry Pi. Plus others like Odroid, Pine64, Radxa, there are many. Among the more affordable options domestically, relatively inexpensive ones include the OrangePi I'm using. Naturally, there are other Pi devices too. Some are quite renowned. Take the chip company behind this one. A publicly listed firm. Allwinner Technology. It's based in Zhuhai, I believe. They specialize in single-board computers. Alright, enough chit-chat. We'll skip straight to the point here. If you've never heard of these before, or never played with one, just search for it on Taobao. Buy an OrangePi. They're available overseas too. The Raspberry Pi is relatively pricier. Since it's British, the copyright belongs to the UK, so we might be talking about that so-called copyright premium, right? Manufacturing for these is mostly done domestically. Take the OrangePi, for instance. Raspberry Pi production also happens in China. OrangePi comes in various models too. The models differ mainly in specs. I haven't researched the latest version myself. Recent models likely have higher specs. The one I have here has 4 GB RAM. 4 GB is pretty decent these days. If you can get your hands on an 8 GB single-board computer, that's already incredibly powerful. Some might even include computing capabilities. The recent news is about this TPU. Google's TPU can now handle inference too. That's pretty amazing. Then there's RISC-V. RISC-V is essentially a new architecture, though its performance is reportedly still behind ARMs. Alibaba's smart glasses apparently use RISC-V. RISC-V is also a community-driven organization, and is largely led by Chinese companies. Go download it. It has download links there. Let me check. Here it is. Just follow the instructions exactly. I'm using Balena. If you've ever flashed a board, you know what I mean, right? Extract the .xz file, then install the .xz. After that, flash it onto the SD card. Just pop the SD card in, and you're good to go. Most people who've done this before should know how. If you haven't tried it, it's actually very simple. Really straightforward. You just need an SD card, and this single-board computer. This kind of board, right? You buy an OrangePi, then flash it using Balena Etcher. You can flash it on Windows too. It's not limited to Linux. There's a Windows version for burning too. You can burn it onto the card. After burning is complete, it should work in theory. Personally, I'd go ahead and modify it first. There's a config file under the boot directory. I've already flashed this version. And I've already deployed it. So theoretically, we can take a look. Use sudo vim to open the file under boot. After burning, if you're using Linux, don't use CRUT. Just mount it directly with mount. After mounting it, edit that file. If you use CRUT, it'll run the automated operation script. If it's your first time, you won't be able to handle it. It's too complicated inside. I strongly advise against using CRUT. Just mount it directly. After mounting, edit this file directly. Just like I did. Edit it directly. For example, you have a mount point, right? I don't need a mount point here. Just edit this file directly. Why edit this file? The core reason is to change your IP address. You don't want to use their VLAN. The default is 192.168.0.100. Just modify it to the VLAN you want. As for DNS, let me check if I've changed this here before. For example, it needs to verify DNS. If the DNS server is overseas, it might be slower. My first startup took forever. You'll need a bit of patience. It could take a minute or even two. That's the main thing. Also, the mirror section. For this app's Debian mirror, I highly recommend Nanjing University's site. Just point it to Nanjing University's site. Those are the main changes. After modifying these, mount the SD card, then plug it into the board. Power it up. Just one USB cable. It powers directly from USB. Pay attention to your USB voltage. I've made this mistake before too. Due to power supply voltage issues, a USB hub like the current 65W type is relatively stable for power delivery. I even bought a small UPS at home for this purpose. That provides relatively stable power. It's a slightly more advanced level of operation. After making the changes, it boots directly. After booting, you can log in. Let's go through it again. I just wanted to demonstrate this for everyone. This doesn't seem to be it yet. We'll just SSH in directly. Once we're in, I've obviously set up the key. The default username is either root or the DietPi username. The password is also DietPi. I won't run that here, because I'm using Echo Shell now. The problem lies here. I just want to introduce this to everyone. If you run bin/bash, it defaults to running this. I see this every day. Why should I run this? So I changed it. After changing it, it became this Echo Shell. And with Echo Shell, it won't run this thing. Why won't it run? Because I've talked about these things before. It has this MOTD. Now, for MOTD, it used to be this, vim/etc/pam.d/login. Inside login, it usually has this MOTD. Of course, you can handle MOTD like this. For this session, you can comment out the MOTD. Don't comment things randomly. Only these two lines need commenting out. If you comment the wrong stuff, you won't be able to log in. Personally, I don't care about this thing. This thing just wastes my resources. So I commented it out. But it still didn't work after that. After doing some basic research, I found there's a bash file under etc. Let's take a look at the bash.bashuk file. This file executes all the files under bash/bashuk.d. You can see this dietpi.bash file. This is the absolute core. So every time you log into bash, this is what runs. It doesn't use the MOTD method. Then a bunch of stuff runs here. It sets up a lot of aliases. I finally figured out that in these aliases. No wonder my Echo Shell only shows these DietPi apps, they won't start. If you really want to configure this, just use its built-in runner. For example, we can simply run bin/bash again. It's very straightforward. Then you can use DietPi. It's just like what runs on your first boot. Config, right? That's what it runs. For instance, whether you want sound enabled, basic auto configuration, and essential tools will all be available. You'll figure it out on your first try. Let me briefly check this. I installed Fast Fetch. The main difference from Debian 13 is its shell uses dropbear, not OpenSSH. You can see this with the pstree command. Relatively speaking, with this free M option, you can see its resource usage is quite low. Around 200 megabytes is sufficient. Because I've already got SS Server, NSD, HaveGed, and these things running here. Generally, they don't run by default. That's because I installed them earlier. Of course, it also includes setting the time zone, and all these things can be configured, right? So basically, we've already installed DietPi. It essentially enhances the capabilities of its pre-configured software. For example, its Software Options feature. It can handle things like HA proxy. You can configure load balancing within its settings and run it seamlessly. This includes Nextcloud, which we use for cloud storage, and SyncThing, which is pretty good too. Then there's MinIO, which is cloud storage. You can set this up at home. And similar to Bitwarden. I have Bitwarden, right? Earlier I mentioned more software options. There's not much else to say about this. We'll wrap it up here. Essentially, it's running a slimmed-down version of Debian 13. So how do you deploy it? Alright, that's it for this video.